Hello, and welcome to my Pre-Algebra review series. This video covers Chapter 5, Section 3, titled Adding and Subtracting Fractions. By the end of this section, you'll have reviewed the procedures for adding and subtracting fractions. This will include simplifying with like denominators, simplifying with unlike denominators, and adding and subtracting mixed numbers. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Okay, objective 1, adding and subtracting fractions. So using models to add fractions. So in this first case here, we have a model which is fifths. As you can see here, there are 1, 2, 3, 4, 5 tiles. And we're selecting one of them, so that's 1 of 5, which is 1/5, 1 of 5. Okay, and the other set of tiles is 2 of 5. So here it is, 2 divided by 5, or 2 of 5 is another way of saying 2 divided by 5. So if you take 1 of 5 plus 2 of 5, and you add them together, you get 3 of 5. Because you see they line up. These line up, they all add up, and they're all fifths. They're the same size tiles. We end up with 3 of 5. So that's our answer here. It's going to be 3/5. And the same thing here with this other model, but they're not the same. They're not fifths. So this is 1/4. 1 of 4 tiles and 2 of 3 tiles. Well, they're not the same size. As you can see, they don't line up together correctly, right? There's a difference in size. This one ends before this one ends. So we have to have smaller pieces in order to divide these and add them together. These have to be divided into smaller pieces, equally the same pieces. Well, the way to get them is if you multiply the two denominators together, you'll get 3 times 4, you'll get 12. And as you down here, we have 12 tiles in red. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tiles. And as I line these up like we did the fifths on the left-hand side, we take the 1/4 and we start the 2/3 right at the end of the 1/4. Well, the 1/4 fills how many tiles? 1, 2, 3 of the 12 are taken up by the 1/4. We have 3 of the 12s. Now we have 2/3 here, and these 2 here take up how much space? From here, 1, 2, 3, 4 tiles. 1, 2, 3, 4 tiles for one of these, because 3 goes into 12 4 times, or 4 goes into 12 3 times. So now we have, and plus 1, 2, 3, 4, the other remaining 4. So now we add all these together, we get these 3, 1, 2, 3, and 4 plus 4 makes 11. 11 twelfths. Okay, so now answer some questions. Referring to the model of the 1/5 and 2/5, what does the resulting fraction equal? Well, we know now, we did it. It's 3/5. The sum of any two fractions can be written as a fraction. Write a conjecture about how to find the numerator and such a sum. Well, I think the conjecture would be that you can add numerators, N-U-M-E-R-A-T-O-R, numerators, add numerators when, I'll just say when denominators are equal. Okay? So that's a conjecture that we can use for this first set. So it says refer to the model with the 1/4 and the 2/3. What resulting fraction does 1/4 plus 2/3 result in? Well, we know that it's 11. I'm going to write it like this: 11 twelfths. I'll use that line as the middle point there. 11 twelfths. Can you add the numerators to find the sum? No, you cannot. 1 plus 2 is 1 plus 2 is 3, and the answer is 11. How about in denominators? Can you add the denominators to find the sum? Again, the answer is no. The denominators are 3 and 4, and the answer, the correct denominator is 12. So 3 plus 4 does not equal 12. In the model of 1/5 plus 2/5, can you see that the sum or difference of fractions with the same denominator is the sum or the difference of the numerators? The denominators don't change in that case. Okay, good. Example 1, simplifying with like denominators. So these are like denominators. It's going to be the first example. These should be pretty straightforward. So it says, find each sum or difference. Oh, it says of difference, but it should say or difference. Sorry. Simplify if possible. So the question says 1/8 plus 3/8 is equal to what? Well, 1/8, that's already written here. 1/8 plus 3/8 is equal to 1 plus 3/8, which is equal to 4/8. And it says simplify if possible. 4/8 simplifies down to 1/2. There's that simplification there. Let's do this one. This one has there's a variable x for the denominator, but guess what? It's the same denominator. So we're going to write it here. We're going to say 9x minus 7x is going to be equal to 9 minus 7 over x. And 9 minus 7 is equal to 2 over x. Is that simplified as best as it can be simplified? The answer is going to be yes, because you can't do anything with the x. That's it. Completely simplified. 2x. Okay, example 1. Check your understanding. It says, find each sum or difference and simplify if possible. Well, as before, I think you know what we're going to do. We're going to pause the video. You can try them yourself. When you're done, come back and we'll solve them together. Okay, now that you're back, we're going to go ahead and try some of these and see what comes up. So it looks like these are the same denominators. So what we're going to do is we're just going to say 3/7 plus 1/7 is equal to 3 plus 1/7. And that equals to 4/7. Can that be reduced any further? No, I think that this is reduced and simplified as much as possible. Answer 4/7. The next one, B. 2k plus 3k. And the variables, they're fine. They're like, so we can just add, we can add the numerators. So that equals 2 plus 3k, and 2 plus 3k equals 5k. And that is as simplified as it can get, because you can't do anything with the 5 and the k, because we don't know what the k is. Now, how about 7/10? 7/10 minus 3/10. That equals 7 minus 3/10. 7 minus 3/10 equals 4/10. And that can be reduced, can it not, to what? 2/5? 2/5. Because we divided the top, the numerator and denominator, both by 2. Okay? The last one, D. 11 y's and yths, whatever you want to say, plus a negative 7 y's. And that is equal to 11 plus a negative minus 7 over y. And 11 minus 7 is 4 over y. And the 4 and the y cannot be simplified any further. Answer here, 4y. Okay, example 2, simplifying with unlike denominators. Simplify each difference down below. We'll look at it here. Before you can add and subtract fractions with unlike denominators, first write the fractions with the common denominator. The method shown here for addition works with subtraction too. So what we're going to do is find how to get the common denominator. We're going to start with the algebra side, I think. Because what it's saying here is if you take the fraction a divided by b plus the fraction c divided by d, see two different denominators. Okay. In order to resolve this, you're going to take and you're going to multiply the first fraction, the a divided by b, by the numerator and the denominator of that first fraction, each by the denominator of the other fraction. So of the d from this fraction, the c over d, here's the d's. So we have, on the first fraction, we have a divided by b times d over d. And for the second fraction, the c over d fraction, we have the c over d times b divided by b, which is the denominator of the first, and the denominator of the second. So the first fraction gets multiplied, the top and bottom, numerator, denominator, by the denominator of the other fraction. Okay, and then once you do that, you're going to find out that you're going to have AD over BD, plus BC over BD. Once that's simplified. So now you see we have a common denominator. The BD is common, and it just so happens to be the denominators multiplied together. We started multiplied together. So now we have AD plus BC over BD, the common denominator. Mathematically, arithmetically, here's what it looks like. 2/3 plus 1/5. So we're going to multiply the 2/3 by 5 over 5, which is the denominator of the second fraction. And the second fraction, the 1 over 5 right here, we're going to multiply by 3 over 3, which is the denominator of the first fraction. So it's kind of like a cross multiplication thing going on there, right? So 2/3 times 5 over 5 and 1/5 times 3 over 3, the alternate denominator. And when you do that, you're going to get, on this side, you're going to get 2 times 5 is 10, 3 times 5 is 15. You're going to get 10/15. I did the numerators, and I did the denominators. Same thing here. Numerators, 1 times 3 is 3. Here it is. The denominators, 5 times 3 is 15. Here's the 15 right here. The 15 is common. So now the answer is 10/15 plus 3/15, 13/15. That's that answer. That's how this worked out in the algebra here. So let's do A. A says 1/8 minus 5/6. Well, what we're going to do is we're going to take the first one, the 1/8. Oh, here we're rewriting it. Is equal to what? It's equal to 1 times 6 over 6. You see, this is a little trick going on here. Here's the 6 over 6. And you see we're multiplying these two already. We're multiplying those two together. But it's still over. It's still 6 over 6. And then the other one is 8 times 5. Here's the 8. 5 times 8 over 8. Here's the 8 over 8. And here's the 6 over 6. 8 over 8. So the 5/6 gets multiplied by 8 over 8. And the 1/8 gets multiplied by 6 over 6. And when you do that, you end up with 6 minus 40, because 6 minus 8 times 5 is 40. And the denominator here is 48. 8 times 6 is 48. So 6 minus 40 over 48, and that equals minus 34 over 48. And when you reduce that down, that ends up being minus 17/24. Right here, minus 17/24. Let's do it here. It's the same problem, but they've thrown a hook at us. They put an X in here. Oh, that's not a 5. It's my, darn it, come on. There you go. It's my scribbles. Okay. Sorry for the scribbles. So we're 1/8 times the 6 over 6 and minus 5x times 8 over 8. The kind of the cross multiply thing going on there, right? So here it's rewritten. Here, 1 times 6 over 6. Here's the 6 over 6. And minus 8 over 8 times 5x. When you do that, you're going to get 6 minus 40x. Here it was 6 minus 40 over 48. 6 minus 40x over 48. There's nothing more you can do. You can't add them together. This is as far as you can go with that. You can't factor the x out. I mean, if you did, you'd have to have a 6 over x if you factor the x out on this side. So you can't do anything with it. So our answer is simplified right there. Okay, example 2, check your understanding. So as before, you're going to stop the video, I hope, and try these on your own. And what it's asking for is to simplify each sum or difference. Okay, so you go ahead and stop it. When you get back, we'll finish it up. Okay, now that you're back, let's start with A, 2/3 minus 1/5. So we're going to start just easily. It's always a process. Remember, always a process. In this case, start with the very first fraction. And you end up with 2/3 times 5 over 5. Remember, you use the denominator from the other fraction. Minus 1/5 times 3. Here's the 3 over here. 3 over 3. And when we multiply this out, we get 10 over 15. 3 times 5 minus 1 times 3 is 3 over 15. We now have like denominators, so we can just go ahead and add or subtract the numerators, and that ends up with 7/15. Done. Go to the next one. Minus 7/8 times, here's the 4 over here, 4 over 4. Plus 3/4 times 8 on this side, 8 over 8. And when we multiply it out, we get minus 7 times 4 is minus 28. Minus 28 over 8 times 4 is 32. Plus 3 times 8 is 24. Over 4 times 8 is 32. There we are with our common denominators again. And when we add these together, we end up with negative 4, because we have 24 minus 28 plus 24. We have minus 4 over 32. And we can divide 4 into 32. We get 8. So that equals minus 1/8. Okay? And then we go over here and we have 3 divided by 7 times m over m. This is a perfectly good denominator. It's a variable, but it's perfectly good. And we're going to subtract from it 2m times the denominator on the first fraction, which is 7s. 7 divided by 7. And that's going to equal 3m. 3m divided by 7m. 7m minus 2 times 7 is 14 divided by 7m. 7m. And what can we do with that? Can we there's no m's on the top. We have 7 m's on the bottom, which is what we want. So this really ends up being 3m minus 14 over 7m. Okay? Good. Okay, objective 2, adding and subtracting mixed numbers. So they're just telling us some information here. It says, before you add or subtract numbers, write the mixed numbers as improper fractions. So before you add or subtract these fractions, write mixed numbers as improper fractions. Okay, here we go. Example 3. It's a real-world problem. Suppose you hiked 2 2/3 miles near Mount Sashta and then another 1 3/4 miles to your campsite. How far did you hike in all? So we're going to add these two fractions. Well, it's mixed numbers. And what did it say to do previously? It said to convert them to improper fractions. So we're going to start off by converting 2 2/3 to an improper fraction. And we do that how? We multiply the denominator times the coefficient, or the integer value here, which is a 6 plus 2. So we get 6 plus 2 is what? 8. 8/3 plus 4 times 1. 4 times 1 is 4 plus 3 is 7. Plus 7/4. Okay, now we're going to do the same thing we've done to everything else. We're going to take and we're going to write 8/3 times 4/4, 4/4, plus 7/4 plus 7/4 times 3/3 over 3. Okay, we're going to multiply them together. 8 times 4 is 32. And it's a 12 on the bottom. 12. Plus 7 times 3 is 21 over 12. And we can add those together. 32 is 53. 30 and 20 is 50. And 2 and 1 is 3. So it's 53 over 12. Okay, and then, so what can we divide? Well, what we can do is get rid of the improper fraction at this point. We're not going to have to divide anything out. So let's see, 12 goes into 53 how many times? Goes into there 4 times, because 4 times 12 is 48. And when you have 48, here we're left over with 5/12. So miles. This person hiked in all 4 5/12 miles. Okay, example 3, check your understanding. Find each sum or difference. Simplify if possible. And as we did before, go ahead, please stop the video. Try these on your own. Take as long as you like. Come back when you're ready, and we'll finish them together. Okay, now that you're back, let's start the first one, A. So 5 3/4 converting to an improper fraction is 23. 23 over 4 plus 7/8. Okay, so now we're going to do the cross multiplication of the denominator, so to speak. It's not really a cross multiplication, but we're going to call it that anyways. So it's 23 over 4 times 8 over 8 plus 7 over 8 times 4 over 4. We multiply it out. 23 times 8, 8 times 20 is 160, plus 24 is 184, 184, and the denominator is 32, and it's plus 28, 30 seconds. There we go. These can be added together now, and we add 184 and 28, we get 204 plus 8, 212. 212 over 32. And if we take that and we divide 32 into 112 to convert this back to a mixed number, we get 6, because 6 times 30 is 180 and 12 is 192. And 212 minus 192 is 20 over 32. And that equals 6. 20 can be divided by 4, and 32 can, and 5/8. 6 and 5/8. B. Let's try B. Starting off, 3 times 5 is 15 plus 2 is 17 divided by 3 minus 3 times 6 is 18 plus 1 is 19 divided by 6. Now we're going to multiply 17 thirds times 6 over 6 minus 19 sixths times 3 over 3. And we get 17 times 6 times 10 is 60. 42, it's 102 eighteenths. 6 times 3 minus 30 and 27 is 57. Eighteenths. And if we subtract these, we get, there it is, 45 over 18. And now we're going to convert this to a mixed number. 18 goes into 45 2 times. It ends up 36, right? And with a 9 remainder. So we're going to get 2 and 9 eighteenths, which is equal to 2 and 1 half. Okay, there's the answer for that one. Let's try C. So we're starting off here. 2 times 8 is 16 plus 3 is 19. 19 over 8 plus 7/8. And now we're going to multiply. Oh, they're already 8s. They're both 8s already. So we can just add these directly. We don't have to go any further. There's no further necessary in this case. So we're going to add 19 and 7. And what do we, because we're adding them here. 19 and 7 gives us what? So 26. 26 over 8. Okay, and what does that equal to? 28 goes into 26 3 times. So that equals 3, and it's 24, right? 2 8ths equals 3 and 1/4. 3 and 1/4. Okay, a recipe for punch calls for 1 1/2 quarts of orange juice, 1 1/4 quarts of ginger ale, and 3/4 of a quart of cranberry juice. How many quarts of punch will this make? So they want us to add those together. So let's just start off. 1 1/4 is, we start without even writing the equation. Well, I'll go ahead and write it. So it's 1 and 1/4 plus 1 and 1/2, 1 and 1/2 plus 3/4, 3/4. So when we do that, I got these two backwards, but it doesn't matter. So 4 plus 1 is 5/4, 5/4 plus 3/2 plus 3/4. So right off the bat, what are we going to do here? We're going to have to convert this one to 4. We don't have to multiply everything. We can, but we don't have to. We can just multiply this one by 4 by 2 over 2, right? Because that'll give us 6 over 4. So then we can add them all together. So it'll be 5/4 plus 3/2 times 2 over 2 plus 3/4, and that equals 5/4 plus 6/4, 6/4 plus 3/4, and that equals 5 and 6 is 11, and 3 is 14, equals 14/4. And 14/4, if you factor this in, this will get 3 and 2/4, or equals 3 and 2/4 is equal to 3 and 1/2. There's our answer. Good deal, everyone.